ground fault circuit interrupter circuit breaker will not interrupt and disconnect service to the house in the case of a disconnected or loose neutral. A ground fault circuit interrupter circuit breaker monitors the difference in current between the hot and neutral conductors. If it detects an imbalance unaccounted for current, it trips and opens the circuit. In the scenario described, both phase conductors are energized, but the neutral is severed. This means that there is no current flowing through the neutral, and the ground fault circuit interrupter circuit breaker will not detect an imbalance. Therefore, the ground fault circuit interrupter circuit breaker will not trip, and the service will remain connected to the house. A two-pole ground fault circuit interrupter circuit breaker has two separate poles that connect to the hot and neutral conductors. It has a transformer that measures the current flowing through each pole. If there is an imbalance between the current flowing in and out of the circuit, the ground fault circuit interrupter circuit breaker trips and opens both poles. In the case of a disconnected or loose neutral, the current flowing through the neutral pole will be zero. This will not cause an imbalance in the current, and the ground fault circuit interrupter circuit breaker will not trip. To protect against the hazard of a disconnected or loose neutral, a main circuit breaker with a neutral fault detection function is needed. This function monitors the voltage on the neutral conductor and trips the circuit breaker if the voltage drops below a certain level. This will interrupt the service and prevent the house from being energized with an unsafe neutral condition. Considering the operation of a ground fault circuit interrupter, understanding its fundamental principle is key. The ground fault circuit interrupter operates by monitoring the current balance between the hot and neutral conductors. Under normal operating conditions, the current flowing through the hot conductor should be equal to the current returning through the neutral conductor. The ground fault circuit interrupter measures this balance using a differential transformer. This transformer encircles both the hot and neutral conductors. If the currents are equal, the magnetic fields produced by each conductor cancel each other out, and no current flows in the transformer's secondary winding. However, if a ground fault occurs, some of the current from the hot conductor will flow through an unintended path to ground, such as through a person touching a live wire and a grounded object. This creates an imbalance between the current in the hot and neutral conductors. The differential transformer detects this imbalance, and the resulting current in the secondary winding triggers the ground fault circuit interrupter to trip, quickly disconnecting the circuit. The typical tripping threshold for a ground fault circuit interrupter is around 5 mA. This is a very small amount of current, but it is enough to cause a dangerous shock. By tripping quickly at this low current level, the ground fault circuit interrupter can prevent serious injury or even death. Now consider the specific scenario of a disconnected or loose neutral. When the neutral conductor is completely severed or has a high resistance connection, the normal current path is disrupted. While the hot conductors remain energized, the current cannot return to the source through the neutral. In this situation, the ground fault circuit interrupter will not detect a current imbalance in the way it is designed to. The current through the hot conductor is still present, but because there is no return path through the neutral, no current flows through the differential transformer. Consequently, the ground fault circuit interrupter does not trip because it does not perceive a ground fault condition. The ground fault circuit interrupter is designed to detect current leakage to ground, not the absence of current in the neutral conductor. It's important to recognize the limitations of a ground fault circuit interrupter in this specific scenario. While it provides excellent protection against ground faults, it is not designed to address issues related to a broken or disconnected neutral. A two-pole ground fault circuit interrupter functions similarly to a single-pole ground fault circuit interrupter, but is designed for circuits that require two conductors, such as 240-volt circuits. It monitors the current balance between both hot conductors and the neutral conductor, if present. If an imbalance is detected, it trips both poles, disconnecting the entire circuit. The internal components of a two-pole ground fault circuit interrupter include a differential transformer, a solid-state electronic circuit, and a switching mechanism. The differential transformer monitors the current in each conductor, and the electronic circuit analyzes the transformer's output. If the current imbalance exceeds the tripping threshold, the electronic circuit triggers the switching mechanism to open both poles of the circuit breaker. Now consider why a two-pole ground fault circuit interrupter will also not trip in the case of a disconnected or loose neutral. Similar to the single-pole ground fault circuit interrupter, the two-pole ground fault circuit interrupter relies on detecting a current imbalance caused by current leakage to ground. With a disconnected or loose neutral, there is no current return path. Thus, no current imbalance occurs that the ground fault circuit interrupter can detect. The absence of a neutral connection prevents the normal current flow, but it doesn't create a ground fault condition. As a result, the two-pole ground fault circuit interrupter will not trip, leaving the energized conductors still connected to the load. This highlights the need for a different type of protection mechanism specifically designed to address neutral-related issues. Therefore, the importance of a neutral fault detection function in the main circuit breaker cannot be overstated. This function is specifically designed to monitor the integrity of the neutral conductor and to take action when a problem is detected. A neutral fault detection function typically works by monitoring the voltage between the neutral conductor and ground. Under normal conditions, the neutral conductor should be close to ground potential, ideally 0 volts. However, if the neutral conductor becomes disconnected or develops a high resistance connection, the voltage on the neutral conductor can rise significantly. This voltage rises due to the imbalance in the loads connected to the different phases of the electrical system. When the neutral connection is compromised, the return path for the current is disrupted, causing the voltage to shift. The neutral fault detection function senses this voltage rise and, when it exceeds a predetermined threshold, triggers the main circuit breaker to trip. This disconnects the entire service, preventing any further hazards associated with the faulty neutral connection. The specific threshold voltage for tripping the circuit breaker with a neutral fault detection function is typically set to a level that indicates a dangerous condition but avoids nuisance tripping due to minor voltage fluctuations. This threshold is usually determined by electrical codes and standards, ensuring a safe and reliable operation. The presence of a neutral fault detection function provides an additional layer of protection beyond that offered by ground fault circuit interrupters. While ground fault circuit interrupters protect against current leakage to ground, neutral fault detection protects against problems with the neutral conductor itself. The combination of both types of protection provides a more comprehensive safety net for electrical systems. Understanding the workings of these protective devices is essential for electrical professionals and homeowners alike. It allows for informed decisions about the types of protection needed for a particular electrical system and ensures that the system is properly installed and maintained. In summary, a ground fault circuit interrupter circuit breaker is designed to detect current imbalances caused by ground faults and will not trip in the event of a disconnected or loose neutral. A two-pole ground fault circuit interrupter operates similarly and also will not trip in the same scenario. To protect against the hazards of a disconnected or loose neutral, a main circuit breaker with a neutral fault detection function is required. This function monitors the voltage on the neutral conductor and trips the circuit breaker if the voltage rises above a certain level, providing critical protection against potentially dangerous conditions. Understanding the limitations of ground fault circuit interrupters and the importance of neutral fault detection is crucial for ensuring the safety and reliability of electrical systems.